Okay, we are now talking about balancing equations. First thing you want to do in balancing equations is you want to divide the reactants from the product. Here on the left side of the equation, or left side of the arrow, you have the reactants. On the right side you have the products. So let's draw a line down the middle separating the two. Okay, next thing you want to do is, now that you have, get that to focus, now that you have separated the reactants from the products, next thing you want to do is you want to underline them. Next, we are going to identify the atoms involved. Here we have, on the left side, we have a B involved, and we have a BR, we have an H, and we also, since this is in parentheses, since the NO3 is in parentheses, we're going to treat this NO3 here together as one. On this side you have three NO3s. What this parentheses means that there is an NO3 together. There's three NO3s. So we're going to treat that as one molecule. Essentially what this is you have a N, and you have an O, you have an O, and you have an O. This is what you have. You have a NO3 molecule essentially, and with this number 3 here is saying that collectively this NO3 in parentheses, there's 3 of these. So since this is in parentheses, the NO3, we're going to treat the NO3 as one entity. So on this side, how many NO3s are there on this side? There's only one NO3, so we're going to put NO3 equals 1. Okay, now how many H's do we have? We have one H. How many BRs do we have? We have 2 BRs. And how many we have 6 BRs. And how many B's do we have? We have 2 B's. Okay, on this side we have 1 B. We have 1 BR. We have 1 H. And we have, since it's in parentheses the NO3, we're going to treat that as one collective molecule. We have 3 NO3s. Next thing you want to do is you want to look at the largest number out of these. Here we have the BR. Out of these 1, 2, 3, 4, 5, 6, 7, 8 numbers, the largest number out of 2, 6, 1, 1, 1, 1, 1, and 3, the largest number out of these 8 numbers is the 6. So let's start with balancing out the BR. This side we have 6 BR, on this side we only have 1. To make this balance out with 6, we put a 6 coefficient. Remember, you cannot put the coefficients in between molecules, and you also cannot change subscripts. So since I want this BR to be 6, I can't just put a little 6 over here. I can't do that. I cannot put a little 6 over here. I have to put the 6 in the front, which is the coefficient. Now this 6 also affects the H as well as the BR. So this 6 makes the BR worth 6, but it also makes the H worth 6. Okay, next on this side, let's look at the biggest numbers. Here we have a 6 out of all these numbers. The 6 is the biggest number. Let's balance out this 6 to match up this H1. To make this H1 worth 6, you put a coefficient in the front. This 6 makes the H worth 6, but it also makes the NO3 collectively worth 6. So we have 6 NO3s. Okay, remember, we're still treating this NO3 as one molecule, since this NO3 over here is in parentheses. Okay, now next, what do we have to match up? Let's look at the NO3 on this side. Let's look at the NO3 on this side. So to make this NO3 match up with this NO3, we have 3 NO3s. We put a 2 here. 2 times 3 gives you 6 NO3s, but it also gives you 2 B's. And now you take a look, you got 2, 2, 6, 6, 6, 6, 6, and a 6, and now you have a balanced equation. So things to keep in mind, just be sure to, whenever you see parentheses, to treat these as one molecule like this. For example, on this side you had NO3, which only had one NO3. Before, you basically had this, but now you have 6 NO3s on that side, and now you have 6 on this side. So that's balancing equations.